So we're going to work on the same thing that we did yesterday, multi-step equations, but we're going to add in something called the distributive property. And all the distributive property is when you have parentheses and something in front of the parentheses, we are going to distribute that item in front of the parentheses into everything inside the parentheses by using multiplication. So we're going to take 2 times y and we're going to take 2 times 6. And then that will clear the parentheses and we can drop the parentheses out of there. So 2 times y is 2y and 2 times 6 is 12. So we're going to put a plus 12 here equals, we're going to bring down the 3y. So draw your line. Now we're going to do what we did yesterday. We have to solve the equation for y, but we have a y term on the left and a y term on the right. So you have to decide, do I want to move the 2y or do I want to move the 3y? Because the 2y is smaller, I choose to move the 2y. The opposite of a positive 2y is a negative 2y. So I'm going to subtract 2y from both sides. I'm going to bring down the 12 equals, and then 3y minus 2y is y. So we have now solved for 1y, and we're done. And so we're going to mentally check. We're going to replace the y here with the 12 that we came up with. So 12 plus 6 is 18. 18 times 2 is 36, so this side equals 36. Then we replace y with 12 again. 3 times 12 is 36. 36 equals 36. I think that's it on this sheet. Yep, so next sheet. So example 2, now the parentheses are on the right side of the equation. Don't let that bother you. We're still going to distribute through multiplication the 3 into everything in those parentheses. So we can't do anything with the left side. 2k and 5 are not like terms. 5 does not, the negative 5 does not have a k. So we're going to bring those down. But we are going to distribute the 3. 3 times 1 is positive 3. 3 times a negative 2k, a positive times a negative is a negative. And then 3 times 2 is 6. And then tack on the k. Whoops, that doesn't much look like a k. I'll rewrite the whole thing. So minus 6k. So now we've cleared those parentheses. There's no like terms here to collect. There are no like terms here to collect. But we have a k term on the left and a k term on the right. You have to decide which is smaller. The negative is always smaller than the positive, so I choose to move the negative 6k. The opposite of negative 6k is positive 6k. So the 6k's cancel. 2k plus 6k is 8k. Bring down the minus 5 equals, bring down the 3. Now we need to get the 8k by itself. So we have to get rid of the minus 5. The opposite of subtracting 5 is adding 5. Bring down the 8k equals 3 plus 5 is 8. We need to undo multiplying by 8 to solve for k. So we're going to divide this side by 8 and the left side or the right side by 8. The 8's cancel and we get k equals 8 divided by 8, anything divided by itself is always 1. And if you want to check, replace k with 1. 2 times 1 is 2, minus 5 is a negative 3. 2 times 1 is 2, 1 minus 2 is negative 1, times 3 is negative 3. It checks. This one's a little bit more complicated. We have collecting of like terms here, and we have a parenthesis. So we're going to put everything that we learned yesterday together with what we just learned in the last two equations. So draw your line, and let's look at the left side separately from the right side. So on the left side, you want to look for like terms. These two terms here both have an a. So I'm going to collect these two because they're alike. Once you identify that they're like terms, just look at the coefficients. A negative 6 and a positive 4, different signs subtract. Keep the sign the larger, then you'll be exact. So we get negative 2a. Bring down the 4 from here. We didn't do anything with it. And don't forget your equals. Then on the right side, we have to decide, are we going to do negative 1 minus 5, or are we going to do a negative 5 distributed into the parentheses? Order of operations say, please excuse my dear Aunt Sally. So we always do parentheses first. And we're not just distributing a negative 5 or a 5, we are distributing a negative 5 into the parentheses. The negative belongs to the 5, so that's what we're going to distribute. So we're going to bring down this negative 1 because we can't do anything with it yet. And then a negative 5 times a positive 7 is a negative 35. And a negative times a negative is a positive. 5 times 2a is 10a. We still cannot do anything on the left side, so bring down the 4 minus 2a. However, on the right side, we have two numbers, a negative 1 and a negative 35. There's nothing with an a, so this is not a like term to anything. But we can combine these two. A negative 1 plus a negative 35 is a negative 36. Then bring down the plus 10a. And now we have fully simplified the left side and the right side. However, we have an a term on the left and an a term on the right. So you have to decide which one you're going to move. Are you going to move the negative 2a to the right, or are you going to move the 10a to the left? Well, which one's smaller? Negatives are always smaller than positives, so I choose to move the negative 2a by adding its opposite. So the opposite of minus 2a is plus 2a. So add a 2a to both sides, and you get a 4 equals negative 36. Add the 10a and the 2a, and you get a positive 12a. We want to get 12a by itself, so we have to get rid of minus 36. The opposite is adding 36. 4 plus 36 is 40 equals 12a. We have to undo multiplying by 12, so we are going to divide both sides by 12. The 12's cancel. We have an a on the right, and then 12 does not divide evenly into 40. So you're going to reduce this fraction. So what's the biggest number that divides into 40 and into 12? 2 divides into both 40 and 12, but it's not the biggest number. So keep going. The biggest number that divides into both of them is 4. So I'm going to essentially divide this by 4, and I'm going to divide the 12 by 4. So 40 divided by 4 is 10, and 12 divided by 4 is 3. And we're done.